Hey there, Math Oneers. Welcome back to online classes, I guess. We are going to start Chapter 9 this week. I am thinking that most likely, well, at least at this point, we are not going to have a test on the circles, though I may continue to put some on homeworks. We'll see. Let's see how things go the next couple weeks before we decide if we need to have a test or anything like that on the circles. So today we're going to start Chapter 9. We will probably have 4 assignments this week and 4 assignments next week. And I'll probably give you, well, I don't know. We'll see. Anyway, we're going to start the first section of Chapter 9 here today. Let's get set up. It's not very hard, and get going. Okay, so hopefully you have printed these out or you're doing them on notebook paper. Chapter 9 is all about inequalities. All right? We're going to start with stuff here I'm pretty sure most of it you'll know. Maybe you'll pick up a little tidbit here or there in the first section or two. We'll see. So as I wrote here, inequalities, just as the symbol, an equal sign, is used to represent that two quantities are equal in mathematics, the inequality symbols below are used when describing the relationships between quantities that are not necessarily equal. So I hope at this point you already know all 4 of these inequality symbols. I hope you know which way they point. If not, you should learn them at this point. Certainly this means is less than, and then when you have the little bar underneath it, it means less than or equal to. Either one makes it true. And greater than or equal to. So we're going to do 2 things here today. We're going to look at what graphing these looks like and then what solving them looks like. And we're going to start with the graphing. So when you're graphing an inequality in one variable on a number line, right? A number line is what you use when you're graphing with one variable. If there are 2 variables like x and y, you still need to use a coordinate plane, just like equations on a coordinate plane. But for one variable, we graph them with a number line, and there's 3 things you want to look at. 1, circle the number called the boundary point. So if I had like x is greater than 2, 2 would be the boundary point. And so I would put a circle at the boundary point. Second thing is you want to decide, should you shade in the circle or leave it open? Well, that depends on the inequality sign. When the inequality sign has a or equal to, these would have a closed circle. Whereas if they do not have an or equal to, then you still have an open circle. So if I was doing x is greater than 2, I'd have an open circle. And then you want to shade the number line in the proper direction. So if I want numbers that are greater than 2, on a number line, greater than is to the right, and I would shade in numbers to the right of 2. And the only difference here is if I had or equal to, I would include the 2 as part of my answer by shading it in. Right? All right, let's try a few examples. I have a couple here that maybe are new to you. We'll see. We start out with, let's read the directions real quick. Graph some inequalities. I will provide you with a line, which I will try to always do. You should put some tick marks on it. And as far as numbers go, I wrote here that you only need to put in relevant numbers. That means I really only need what we call the boundary point, or the solution number. I don't need every tick mark to be numbered. So for instance, if I am graphing x is greater than or equal to -2, I'm going to put a tick mark at -2. That is really the only relevant number. If you want to put more tick marks, you can, but -2 is really the only number I need that's relevant to this problem. Since it has an or equal to on it, I would make it a shaded circle at -2. And I want numbers that are greater than -2, so I would shade the number line in this direction. How about I want to shade in numbers that are less than 17? The only number that matters is the 17. Maybe I have some other tick marks. So since I do not have an or equal to here, that would be an open circle, because 17 is not one of my answers. And I want numbers that are less than 17, and on a number line that would be to the left. And I've shaded in all the numbers that are less than 17. All right, this brings us to two interesting ones. So you can see this actually has two answers, which means you're going to have two areas on your number line shaded in. First, we have numbers that are less than -3. So I'm going to put the relevant number, -3, on there. And I have numbers greater than or equal to 4. So I also want to put the 4. And you want to make sure you always put the bigger number to the right of the smaller number. And I generally do not put any more tick marks in, though you can if you want to. But then you got to count the right number of tick marks between -3 and 4, and I don't really want to do that. So less than -3 would be an open circle because it's not or equal to, and I would shade all the numbers that are less than -3. Greater than or equal to 4 would be a shaded circle at 4, because it's or equal to, and I want to shade all the numbers greater than, so that would be to the right. So see how I have two areas because there are two inequalities. This is the way an or almost always looks, unless the answer is all real numbers. Or means that for a number to be a solution, which that's what I've shaded in, the solutions, for a number to be a solution, either this has to be true or this has to be true. So if either one is true, it makes it a solution. As opposed to and. Now an and only works if both parts are true. This part has to be true and this part has to be true. And there's actually another way to write an and. You can write it in with what's called an interval, which is where you put the smaller number here, the x in the middle, and the bigger number here. And you have the same two inequality signs. X is less than or equal to 2. Now notice this one. X is greater than -5. So the inequality needs to look like that, so that the x is actually on the greater than side of the -5. These two things are two different ways to write the same inequality. Now on a number line, your solution is numbers that are between -5 and 2. Numbers that are greater than -5, and also they have to be less than or equal to 2. So we put our two relevant numbers, which are the -5 and the 2. Notice that the -5 does not have an or equal to sign, so open circle, whereas the 2 does. And I want numbers that are less than 2, but I'm not allowed to go past the -5, so I'm shading in the numbers in between -2 and 5. And this is typically, unless it's no solution, this is typically what an and looks like. An and almost always has two endpoints with numbers in between. Almost always, unless it's no solution. Well, there is another example, I guess, as well. All right, so let's look at these examples. We have turned it around now. I have given you the graph, and I'm seeing if you can write the inequality. If you want, you can pause the video and try to do it yourself and then come back, or you can just watch as I explain it. All right, this first one looks like it's numbers less than -1. I'm always going to start with an x, or whatever variable you want to use, but I like x. It's an open circle, and it's less than, so it's less than without the or equal to sign, and it's -1. This has two parts, so it looks like an or, right? We got numbers less than -3, so that would be x is less than -3. Or we have numbers greater than or equal to, right? Because it's a shaded circle, so it's or equal to, greater than or equal to 2. All right, here we just have a greater than 1. So I'll start with the x and say that it's greater than 1. And it's or equal to. I almost forgot. Shaded circle means or equal to. And last up, I have one of these segments, right, with an endpoint and an endpoint. This typically means and. So there's two ways I can write this. I can either say x is greater than the -4, and x is less than or equal to the 2, or I can write it as a single inequality as an interval, which would be from -4 to 2. X is bigger than the -4, but less than or equal to the 2. All right, good with those. We got one thing left, not too difficult. And that is solving an inequality. Now listen, solving an inequality is very similar to solving an equation. There's really only, as I said here, a couple of differences. One is in the answer. An equation typically has one solution, like x equals 4, and 4 is the only number that makes the equation true. Whereas an inequality has infinitely many solutions. So like when x is greater than 4, it means that any number more than 4 is a solution, right? So 5, 6, 7, 4.2, 4.3, infinitely many solutions. That's a small thing. This is a big thing. So many people make a mistake on this. When you solve an inequality, as you are solving it, maybe I should circle that, if you multiply or divide both sides by a negative number, you must flip over the inequality sign. Let me do a couple examples that are similar to the homework, and we'll see how this works. So solve each of the following inequalities for the given variable. Represent your solutions on a number line. So first I would solve this just like I was solving an equation. I would add 5 to both sides. I'm going to, instead of bringing down an equal sign, I'm bringing down a greater than or equal to sign. And I'd have 8. I would divide both sides by 2. Get x is greater than or equal to 4. That 4 is called the boundary point. And when I graph it, I need a tick mark at 4 because 4 is the boundary point. It's the only relevant number. Greater than or equal to means a shaded circle. And numbers are bigger than 4 to the right. That's really all there is to it. If you want to put more tick marks in because it looks... Oops, I think I accidentally paused. And then last up, to solve this one, I would start by subtracting 3 from both sides, right? That would get rid of the 3, and it would leave me with -2x is less than -2. And then I would divide both sides by -2. Now this is the number that matters. All right? It doesn't really matter that the top number is negative. It only matters what are you doing on both sides. And since I'm dividing both sides by a negative number, I have to flip the inequality sign over. On this side I get x. On this side, -2 divided by -2 is a +1. I can't tell you how many people forget to flip over that inequality sign. make sure you remember to flip it over when you multiply or divide both sides by a negative number. And to graph this, I would simply draw a number line. I'd put a 1 there because 1 is the boundary point. It'd be an open circle at 1, and greater than 1 would be these numbers here. All right, that's it. Good luck on the homework.